All right, this is section 4.6, graphs of the other trigonometric functions. Last time we talked about sine, cosine, and tangent. So, quick refresher of the tangent function, it is different than the sine and cosine function. You actually won't need to worry about this stuff. It is not going to be tested or covered or anything like that. So let's start with cotangent. To graph cotangent, we get some points. The cotangent of 0, remember that cotangent is x over y. So at 0, the coordinates are 1, 0. So that's 1 over 0, which is undefined. The cotangent at pi over 4 is 1. The cotangent at pi over 2 is 0. And the cotangent of 3 pi over 4 is negative 1. This is all based on our unit circle, remember. So at pi, our cotangent is undefined. Then 1, 0, negative 1, undefined again. Remember that undefined means an asymptote. So on the y-axis, we have an asymptote. At pi, we have an asymptote. At 2 pi, we have an asymptote. 3 pi, 4 pi, 5 pi, negative 1 pi, negative 2 pi, every whole number pi. Then we plot our couple points. So pi over 4, 1. Pi over 2, 0, 3 pi over 4, negative 1. This is very similar to the graph of tangent, but it is kind of scooted over and flipped upside down. Remember that we get really close to the asymptotes on either side. Make sure you go through those 3 important points, and make sure you have arrows on it. Make sure you don't cross your asymptotes. Lots of little things to be careful about here. But in between every set of asymptotes, we follow this same pattern. And we'll get our cotangent graph. So there's the graph of cotangent for you. Important pieces of the cotangent graph. We have vertical asymptotes at x equals any multiple of pi. There are zeros where cosine of x, or theta, is 0. The period is pi, and the first one starts at the y-axis. You'll notice the graph is very similar to tangent, except that it's flipped over, so the whole graph is decreasing, and the asymptotes are scooted over along with the x-intercepts. Really careful here. Tangent and cotangent do not have something called an amplitude, which we will talk more about with sine and cosine, because they don't have maximums and minimums. Amplitudes are those maxes and mins. All right, then it brings us to secant. Remember that secant is the reciprocal of cosine. So it's 1 over the cosine. So at 0, the cosine is 1, so secant is 1. At pi over 2, the cosine is 0, which means the secant is undefined. So I have an asymptote. At pi, the cosine is negative 1, so the secant is negative 1. At 3 pi over 2, cosine's 0, so secant's undefined. At 2 pi, cosine is again 1. And now you probably see the pattern. We have an asymptote at every odd pi over 2, a max or a min jumping back around here like this at the whole values of pi. Oop, there. All right. And on this side, an asymptote to minimum, asymptote to maximum. Now the trick here is what this graph looks like. Because we have these points, but remember that an asymptote is something that you get really, really close to on either side. In between negative pi over 2 and positive pi over 2, cosine is always positive, which means our secant is always positive, which means it must look something like this. It looks like a parabola almost, but it's really not because parabolas aren't bounded on the sides by asymptotes. And this just repeats over and over and over here. And there's our graph of secant. Important pieces of secant. Secant is the reciprocal of cosine. Every minimum of cosine is now a maximum of secant, and vice versa. The asymptotes are where the cosine was 0. Secant takes off where cosine leaves off. Basically, if cosine was leaving off at 0, secant is taking off towards infinity or negative infinity. There are vertical asymptotes at every odd multiple of pi over 2. The period is 2 pi. The first one splits the y-axis. So realize in secant here, one period is 2 full curves, one up, one down. And technically the first period is that, right? Cutting it off on the left, cutting it off on the right. All right, and then cosecant. Cosecant is very closely related to sine. So the sine of 0 is 0. So that means cosecant is undefined. The sine of pi over 2 is 1, so cosecant is 1. The sine of pi is 0, so cosecant is undefined. The sine of 3 pi over 2 is negative 1, so cosecant is negative 1. The sine of 2 pi is 0, so again we have undefined. And now we follow the exact same type of pattern we used with secant. Alternating by maxes and mins and asymptotes. All right, and the graph of cosecant is very, very similar to the graph of secant. Just scoot it over. So we have our parabola-looking things. Not parabolas, because parabolas go forever sideways as well. But these are these kind of U shapes. And there's the graph of cosecant. Cosecant is a reciprocal of sine, remember? Every minimum of sine is now a maximum of cosecant, and vice versa. The asymptotes are when the sine is 0. Cosecant takes off where sine leaves off, so when sine's going to be 0, cosecant is getting to a maximum, not a maximum, positive infinity or negative infinity. The vertical asymptotes are at every multiple of pi. The period is 2 pi, and the first one starts at the y-axis. So with these graphs, you just have to be familiar with them. You do not have to memorize them. You do not have any assignment on them. Just be familiar with their basic shapes.